Welcome to the Deep Dive. Today, we're going deep into AI reasoning with this paper all about DeepSeek-R1.
Hmm.
These models are trying to answer a really big question.
Yeah.
Can we teach computers to think the way we do?
Yeah.
We've got excerpts from the paper,
Okay.
DeepSeek-R1, Incentivizing Reasoning Capability in LLMs via Reinforcement Learning.
Right.
And I am so ready to break it all down with you.
This research is really interesting. It pushes the boundaries of what we thought AI could do.
For
For the longest time, AI was mostly about pattern recognition.
Right.
But now we're seeing researchers trying to give AI those higher level thinking skills, the kind we use every day to solve problems and make decisions.
It's pretty amazing.
It really is.
One of the things the paper really highlights is just how important post-training is for developing reasoning in these models.
Yeah.
It's like giving the model specialized training after its initial education.
Exactly. It's like, imagine an athlete who shows a lot of promise. You send them to train with a top-tier coach.
Right, to refine those skills.
You really hone those skills, yeah.
And the DeepSeek researchers, they found that just giving a model more time to think during a task, which is called inference time scaling,
Right.
it just doesn't work.
It doesn't cut it. You need a new approach.
And that brings us to DeepSeek-R1-Zero, one of the models they talk about in this paper.
Okay.
This model actually learns to reason just by using reinforcement learning.
Interesting.
It's almost like, you know how you train a dog with treats, but instead of tricks.
Right?
We're talking about really complex reasoning skills.
Yeah, that's fascinating.
The really mind-blowing part is that DeepSeek-R1-Zero learned to reason without any human-labeled examples.
Wow.
So the researchers, they basically set up this virtual playground,
Okay.
and the model just figured everything out on its own.
So it was like self-taught in a way.
It really was.
Ah.
And get this, it even developed these sophisticated behaviors like what they call reflection,
Reflection.
where it would actually evaluate its own steps to see if it was on the right track.
Like a double check.
Yeah, like we might do when we're working on a problem.
That's amazing.
And the results are incredible.
I bet.
DeepSeek-R1-Zero's performance on the Amy math competition, which is a really tough one.
Yeah.
Its score jumped from 15.6% to 71%
Wow. That's a huge improvement.
after it learned to reason on its own.
That's a testament to how powerful reinforcement learning can be. And it shows the model's ability to learn all by itself.
But DeepSeek-R1-Zero wasn't perfect.
Oh.
It had some quirks, like its readability wasn't great,
Okay.
and it tended to mix languages,
Interesting.
which made it a bit less user-friendly.
So not quite ready for prime time.
Not quite, and that's where DeepSeek-R1 comes in.
Okay, so they built on that first model.
They wanted to make it more practical,
Right.
so they used a multi-stage approach to training DeepSeek-R1.
Okay.
And they started with what they called a cold start.
Cold start.
Think of it like giving the model this intensive course in how to communicate clearly.
So kind of like giving it a foundation.
Exactly. They fed it this set of well-structured examples to improve readability.
So they were really focused on the clarity of its output.
Yeah, they wanted to give it a solid base.
Makes sense.
And then came the reasoning-oriented RL, which is similar to how DeepSeek-R1-Zero learned.
Okay.
But this time they focused on very specific reasoning tasks.
Like what?
Things like math, coding, and logic puzzles.
To make sure it could handle those types of problems.
Exactly.
Interesting.
And to refine the model's outputs even more, they used a technique called rejection sampling.
Projection sampling, what is that?
It's like having this quality control team
Okay.
that filters out any bad responses.
So you only get the best ones.
Right. They also used FFT, or supervised fine-tuning,
SFT.
which meant training the model on examples from other areas,
Other areas like,
writing and role-playing, to make it more versatile.
so it could handle different types of tasks.
Exactly.
I see.
And finally, they used RL for all scenarios
RL for all scenarios.
to make sure that no matter what you asked it,
Right.
the model's responses would always be helpful and harmless.
So they really wanted to make sure it was safe and reliable.
Yes, and all of these steps led to some really big performance improvements.
I bet.
DeepSeek-R1 actually outperformed not just DeepSeek-R1-Zero,
Mm-hmm.
but other AI models too,
Wow. So it was better than the competition.
on a bunch of different benchmark tests.
Okay, like what kind of tests?
Like the MMLU, which
Mm.
stands for Massive Multitask Language Understanding Benchmark,
MMLU.
and Live Code Bench,
Live Code Bench.
which evaluates coding skills.
So they really put this model through its paces.
They did, and the results are really impressive.
Yeah, it sounds like this multi-stage training pipeline really worked.
It did, but here's the thing.
What's that?
Training these massive AI models takes a lot of computing power.
Right. It's very resource intensive.
Which isn't something everyone has access to.
Yeah, that's a problem.
So the DeepSeek AI team also looked at something called distillation.
Distillate.
Imagine you have a recipe from a master chef,
Okay.
and you simplify it so anyone can make the dish.
So it's like making it more accessible.
Exactly.
Got it.
That's kind of what they did with DeepSeek-R1.
Oh, interesting.
They transferred the knowledge from this huge computationally expensive model
Right.
to smaller ones,
Okay.
based on open source models like Qwen and Llama.
So they made it smaller but kept the important stuff.
Exactly.
That's really clever. Yeah, they distilled it down to the essentials.
What's amazing is that these smaller models, even though they're smaller,
Right.
they still did really well on reasoning tasks.
Mm.
They even beat out some of the bigger models in some cases.
Wow. So they were able to keep the performance even after shrinking it down?
It's really impressive. It could make advanced AI way more accessible.
Yeah, that would be huge.
The DeepSeek AI researchers were also really upfront about what they tried that didn't work.
Oh, that's interesting. I like when researchers share their failures too.
Me too. It's so valuable.
Definitely, you can learn a lot from what doesn't work.
Like one thing they tried was this process reward model.
Okay, process reward model.
Or PRM.
PRM. And that didn't work.
It was tough because they were trying to reward individual steps in the reasoning process
Oh, I see. So breaking down reasoning into those tiny steps.
and figuring out how to actually evaluate them.
Right, to see if the model was on the right track.
It's a really tough problem.
Yeah, it sounds like it.
They also tried using Monte Carlo tree search.
Monte Carlo tree search, isn't that used in games?
Yeah, like chess and Go.
So how did they try to use that for reasoning?
Well, it's often used for making strategic decisions.
Okay.
But with reasoning, you have so many possibilities to search through.
Oh, right. So the search space is much bigger.
Exactly. And training a value model to guide the search was also really difficult.
Yeah, that makes sense.
So even though those attempts didn't work out,
Uh-huh.
they give us a lot to think about for the future of AI research.
It's all part of the process.
Definitely. So let's switch gears a bit and talk about how they're trying to make this tech more accessible.
Right, because as we said, training these large language models is a huge undertaking,
It takes a ton of computing power.
which not everyone has.
Exactly.
So what did they do?
That's where distillation comes in.
Distillation, we talked about that before.
Right. It's like taking that super complex recipe
From the master chef,
and making it so anyone can cook it.
simplifying it.
That's exactly what they did with DeepSeek-R1.
Interesting, how so?
They were able to take all the knowledge from this massive computationally expensive model and transfer it to these smaller models.
Okay.
They based the smaller models on these open source architectures like Qwen and Llama.
So they took a huge model and made it smaller and more efficient.
Yes.
Cool.
And the results were really impressive.
I bet.
These smaller models, even with their smaller size,
Right.
they were still able to perform really well on reasoning tasks.
It's amazing that they were able to maintain that level of performance.
And in some cases, they actually outperformed some of the larger models.
Really? So sometimes smaller was better.
It seems that way.
That's fascinating.
It could be a real game changer for making advanced AI available to more people.
Yeah, democratizing AI in a way.
Now, the researchers were also very transparent about the limitations of DeepSeek-R1.
Okay, what were some of those limitations?
Well, while it's great at reasoning tasks, it's not as versatile as some other models.
In what way?
Like when it comes to things like function calling,
Okay.
multi-turn conversations, or generating those really complex, creative text formats.
So it's more specialized.
It is.
Interesting.
They also pointed out that it's primarily optimized for Chinese and English.
Okay.
So if you were to give it a prompt in, say, French,
Right.
it might still revert to English for part of its reasoning process or response.
So there are still some language barriers.
There are.
Makes sense.
Another thing they found was that how you phrase the prompt can really affect the model's performance.
Oh, that's interesting.
And actually giving it a few examples beforehand, which is called few-shot prompting.
Right. Few-shot prompting.
It actually made its performance worse.
Huh. So less is more in this case.
It seems like it.
So what do they recommend?
They suggest using what's called a zero-shot setting,
Zero-shot setting.
where you give it a very clear problem statement
Okay.
and tell it exactly what kind of output you want.
So be direct and specific.
Exactly. It seems like DeepSeek-R1 responds best to straightforward instructions.
Makes sense.
Another area they want to improve on is its abilities in software engineering tasks.
Okay, software engineering.
But evaluating those tasks can take a lot of time.
Right, because you have to make sure the code actually works.
And that makes it tough to incorporate them into the reinforcement learning process.
It's a challenge.
It is, but they're working on some solutions.
Like what?
Maybe using rejection sampling on software engineering data,
Okay.
or finding ways to evaluate those tasks more efficiently during training.
So they're not giving up.
Not at all.
I appreciate that they're so open about these limitations.
Me too. It shows a real commitment to continuous improvement.
And it sets a good example for the whole AI research field.
Definitely. It helps build trust and encourage collaboration.
Yeah, absolutely.
It also helps people who aren't AI experts understand what AI can and can't do.
Yeah, there's so much hype around AI.
For sure.
It's important to be realistic about its potential.
Absolutely. So this has been a really fascinating deep dive into AI reasoning with DeepSeek-R1.
It really has.
What stands out to you the most?
You know, I'm really impressed with how committed they are to using reinforcement learning to get true reasoning in AI.
Yeah.
The fact that DeepSeek-R1-Zero could teach itself to reason with no help from humans is just incredible.
It's mind-blowing. It really feels like a breakthrough.
It does.
And it's great that they're working on making it better, fixing the problems, and making the technology more accessible.
Yeah, they're not just resting on their laurels.
Not at all. The way they developed DeepSeek-R1, with that multi-stage training and the way they use distillation to make smaller models, it's really clever.
It shows how much thought and care they put into it.
This paper has given us a glimpse into the future of AI, and it's clear that reasoning is going to be a big part of it.
Yeah, it's a really exciting time to be following AI research.
I can't wait to see what comes next.
Me too. There are so many possibilities.
Well, thanks for joining us on this deep dive into AI reasoning.
It was a pleasure.
Until next time, stay curious and keep exploring the world of knowledge.